Hello, Sunday, March the 5th. This problem seems extremely easy, applying proposition 9. So I guess it's a preparation for later problems. So the sum here, we shall write it as the sum over f of n, or let's say m, where m run through z squared. Apply when t is positive. Then we have functions of fast decrease. I think we should call it f of x instead. So that I don't confuse myself as to what are the variables here. So when x tends to infinity, this tends to naught. It's a function of fast decrease. And since we are only operating with t on the real axis, it's a real function of fast decrease. And this series will converge absolutely. So we can use Poisson's addition theorem, which means that we need to find the Fourier transform. So first we have the Fourier transform of IPT x times x hat of y. It's the same function, y times dot y. That's without the t, by the way. And then when we put in t, I realized last time that we have to take square root tx dot square root tx. So that means that we are using proposition 9.3 here. We're using proposition 9 all the way through, and part 3 says that it's the other guy. Or rather, we should multiply first by b to minus n. That's b square root t to minus first, so it's 1 divided by t. And then the usual function, but with the y divided by t, so it's y squared divided by t. b is square root t, and it's being squared by y squared, so that's why it becomes t. Next, we make the translation. Now what's the translation called? It's called plus u. And the translation, that's the first one. That's mu times y. U, not nu. u times y times the other guy. And finally, we can multiply it and that's number 3 we are using here. Blah, blah, blah. Evaluated at y. And that's just a translation by subtracting v so we've got here f of y equals, so we take the guy up here, this guy, and translate it v and then this part should be equal to some theta function. So the upper guy must be u. Oops. Why there should be, oh, that was the wrong line. It's the part where y occurs. I'll just copy the other side. And then the upper sign, the upper guy, v, is the guy from the exponential. So that's u. And this is minus v. The u part, that's the lower index u. That's what we add, so it's minus v. Evaluated at 1 divided by t. Oh, this is actually wrong. We have to insert all of this because this is what comes from the sum. And now we can do it. There we go. So what I wrote down here is insane, and this is the right. So that's it, guys, for today.